Yes, I think we can begin. So, hello and welcome everyone to the opening ceremony of Singularity 2021, which is the annual science festival of IISER Bhopal. And today we are honored, elated, and simultaneously excited to have HC Verma to have with us. And uh, um, let me just introduce to the people about him. So, Harishchandra Verma Padma Shri is an Indian experimental physicist and professor emeritus of the Indian Institute of Technology, Kanpur. He has authored several school, undergraduate, and graduate textbooks. His most popular being Concepts of Physics. I'm sure everyone has solved at some point of time. He popularized physics by creating a link between what students learn with their real lives. Dr. Verma has developed more than 600 low-cost physics experiments, which teachers can employ in their classrooms. So now I would like to call our secretary Arihant Tiwari to say a few words.
Good evening, sir, and good evening, everyone present here. I am Aryan, the Science Council Secretary and the convener of Singularity 2021. So we are the students of Indian Institute of Science Education and Research, Bhopal. We are a premier institute of research in India, and to increase the scientific amenability in students, we conduct the Singularity Science Fest annually every year. This year, we are glad and very excited to have you as a guest, sir. And I would request you to present us some words of wisdom.
Thank you, Arihant. Thank you, Abhishek. And it's very nice that I said Bhopal student community is doing this kind of activity. And I wish I could address you physically being there.
Yes.
Yeah, so I hope we'll get a chance for that also, because it's always a pleasure to interact with the students. And if it is face to face, then more fun. Okay. Much more fun. Right. So today I had chosen the topic how to learn science, the elements of science learning. Science, as you know, science and science learning both are natural processes. Okay. In science, we try to discover, in science, we try to know what is happening around us, what are the basic rules on which all these events are happening, the natural events, whatever it is, the water drying from cloth, wet cloths, or whatever you can think, the boiling temperature increasing in the pressure cooker, anything you think about. And yes, what are those basic rules on which these things are happening? So it's all natural science. And learning science is also very natural. And I can elaborate on that. What do I mean by that? The learning science is also very natural. Think of a child before going to the preschool. All right. So that means the age less than, say, 3 years. Think of a child of an age 2 years. Right. Now, if you really go deeper into this aspect, you will know that a child of age 2 years knows all the 3 laws of Newton. Newton's first law, second law, and third. Okay. Newton's first law. Just think of a child playing with some toy car. And then he thinks that, okay, fine, is enough. So he keeps the toy car on a side and then start doing something else. And after 15 minutes, half an hour, 1 hour, again he wants to go to the same toy car and explore more on it. What do you think? Where will he go to pick up that toy car again? Huh? Very naturally, we'll go to the same place where he had left that toy car. Why? Why not in a different room? Why not randomly at a different place? all the children of the age 1.5 year, 2 year, if such a thing happens that they had to put something somewhere, and after some time they recall that, okay, I had put it there and I again want to take it, they will go to that place only because they know that if something is kept at rest, it will remain at rest there. It will not be moved from there. And if it is not there, the child will start asking mummy, papa, and siblings, brother, sister, who had taken it? Who had taken it? Who has taken it? Who has taken my toy? What does that mean? Knows that only when the external force acts, the things can be displaced from their state of rest. So don't you think the science learning is so natural? You don't have to teach. You don't have to teach. The child learns Newton's first law so quickly. Second law, you play with that 2 year child in the backyard, have a ball with you, give that ball to the student, to that child, and you are in the catching position and ask the child to throw the ball. And look at the action of his hand. He applies the force in the proper direction so that the ball lands up in your hand. Why not 90 degree from there? Why not 45 degree from there? Why not 135 degree from there? Why not upward? Why not downward? Child has already learned that a force applied in a particular direction can change the velocity in that direction only. That means the acceleration, which we call acceleration, a child will not call it acceleration. See, learning language is different. Learning words is different. Learning science is different. The child has already learned science, but not the words, not the grammar. This is called acceleration. This is called velocity. Okay, fine. But that is not science. If this is called acceleration, that is this particular thing which is rate of change of velocity, blah, 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 is called acceleration. That is not science, that is definition. It's not a law of nature. You could have given any different name, the science would have remained the same. So the science is known to the child that I have to apply the force in this particular direction if I want the ball, the velocity of ball, to be picked up in that direction. And magnitude, proportional to the acceleration. Yes, that also. You stand at a distance of 5 feet and observe the kind of effort this child is putting in throwing the ball. Look at the action of the hand, it will be very clear. And then you increase the distance to 10 feet. And again, the child is trying to throw the ball to you, and look at the action of the hand. You will see that the child is putting extra effort. Knows that, yes, if I want greater acceleration, greater force has to be applied. Newton's second law in vector form, the direction and the magnitude both. Is natural. Science learning is very natural process. Everyone learns that. Everyone learns that. Everyone, whoever has taken birth on this planet. Newton's third law. You ask that 2-year-old child to run in the room from one wall to the other wall and bang the head at that opposite wall. Go running, don't slow down, and then put your head there on the wall. Will the child do that? Who will refuse to obey your orders? Already Newton's third law is known to the child. If I hit this wall with a great force, the wall will hit me back with the same force instantaneously, that time itself. No confusion. No confusion. When you come to grade 10 and 11 and 12 and BSc, Then the confusion starts. Which is action and which is reaction? Which force? Action, reaction, pair. So you have to put great effort in identifying that these two forces are equal and opposite, but they are not action, reaction, pair, and this, then, and that. So the child has no confusion. If I hit the wall will hit me back. So it's A exerting force on B, B exerting force on A. Instantaneous, together, same moment. So natural. Science learning is so natural. But later on, when we come to curriculum-based science learning, then this natural process is lost. Because in curriculum-based science learning, we regiment things, and then it becomes unnatural. When there was no school, there was no teacher, there was no examination, there was no syllabus, there was no semester, there was no classroom. Process was very, very natural. But now we have put so many regimentations. Science will be taught from 9 a.m. to 9:40 a.m. Why? The child had no restriction. Any time, you never know at what time the child has learned all the science. But here, no, the bell goes at 9 and 9:40 the second bell goes. In between that only you have to learn science. After that it will be language class. So that kind of regimentation makes this process unnatural, and our learning process is tuned to the natural process. And therefore there is a mismatch. And then science learning becomes difficult, becomes tedious, you don't enjoy that, and therefore you do not learn that well. Those are the kind of things. So what are the elements, I would say, in this science learning when you are in the curriculum, when you are in the school, college, academic institution? The first thing is cramming. I don't know why people are generally against cramming. Okay, the academicians will say, "Oh, क्या रट्टा मार मार करके खाली नंबर दिलवाते हो, रट्टाफिकेशन होता है, and rote learning, and we have to come out of the rote learning and things like that." But I'm all for cramming. I am all for cramming. Cramming is not a bad thing. Okay. See, when in nursery classes, you ask the child to cram that twinkle, twinkle, little star, nobody says that it's a rote learning without understanding. How many children in nursery KG understand what is twinkle, twinkle, little star? What does it mean? How many children? No one in India. Okay, unless the mother tongue itself is English. And in the first 2 years, in the natural way, the student has learned science and the student has learned mother tongue. Whatever language is spoken in the family, the child has learned that so well by the end of 2 years or 2.5 years. The child can talk very well. In preschool, in nursery classes, when a child is admitted at the age is around 3 years, and how well that students communicate with the teacher, whatever is the communication in that language, if it is in the mother tongue. If it is in the other language like English, then probably difficulties will. If the mother tongue is not English, and the child is admitted to nursery classes, you will have all that Baba, black sheep, and twinkle twinkle, and all those things. Is it not cramming? People are not against that. People enjoy that. But in science, when we say cram it, then they will say, "Oh, this is not learning." Cramming has its own importance. We crammed all those mathematics tables when we were in class, let's say 3-4. That 2 दूना 4, 2 या 6, 6 7 42, 8 8 64. All those methods, those tables, multiplication tables, we crammed. We never knew what it is. We never knew what do we mean by 7 into 8 is 7 8s 56 or 7 56. We never knew. And I'm very happy that I crammed all those mathematics tables at that age without understanding, because that is helping me a lot even today. Even today, when I'm making some calculations, some Archimedes principle, or finding Young's modulus, or time period, and some multiplication divisions are there, without going into calculators and without using pen and pencil, most of the time within 10% I know the answer, because I have crammed all those mathematics tables at the age of 7 8 years. And if someone makes a calculation, and if it is not within 10% of my guess, if it is double of that or 10 times of that, or even 25% off, then I will say that something is wrong. Do it again. Okay, and most of the time that mistake is identified, and the right answer is. So I get a feel of it. I get a feel of that expression. Okay, this expression means this. Crime is okay. When I was in BSc honors, not only school, when I was in BSc honors, I'm talking of 1973, 72, 73, 74. Many of you were not born that time. Okay. So that time we had all long answers. Some 12 questions will be there, or 10 questions will be there in the question paper, and we will ask to attempt any 6 in 3 hours. 6 questions to be written in 3 hours. So for each question we have 30 minutes, but not actually 30 minutes, because in those 3 hours we have to do everything. The stitching of the extra notebook or whatever. We have to read the question paper. We have to properly everything. So say roughly 27 minutes per question. So I had prepared my answers for all possible questions which I could think in all the 4 papers of BSc honors, right? And for that I took all previous year's questions. So examination oriented studies is also not bad. This is another criticism I hear from the commission. सब मार्क्स के लिए पढ़ते हैं आजकल, इसके लिए कोई नहीं पढ़ता है. मार्क्स के लिए एग्जामिनेशन करते हैं, परीक्षा करते हैं खाली. हाँ, वो गलत बात है. परीक्षा करना अच्छी बात है, मार्क्स के लिए पढ़ना अच्छी बात है, लेकिन जो अंत में एक शब्द है, मार्क्स के लिए पढ़ते हैं केवल. That केवल is bad. Only that one word is bad. Otherwise, all fine. So I collected all those question papers, all possible question papers, or question paper, previous year's question paper of some whatever I could get, some 15 years question I collected. And then all the questions which were asked, the superset of all those questions, the union of all those questions, per paper it was hardly 22, 23 questions, because questions are repeating very frequently. So some maximum 23, 24, 22 questions per paper. And then I prepared best possible answers, which could be written in 27 minutes. Editing. Which sentences are to be written in the examination, which are not to be written. So that in 25 to 27 minutes, my answer is complete. And I used to have a clock there, and while writing on the register with my speed of writing, then okay, up to here I can write in 12 minutes, up to here I can write in 18 minutes, and like that. Tailor-made question answers, and I crammed everything. All right, I crammed. I have to write exactly in this fashion. Nothing wrong in cramming. Why not? I get marks for that. Why not? Yes. But then if you stop there, then you are in loss. So although I had crammed all those answers for my BSc Honours examinations, but those answers were not copied from the books. Those answers were not copied from seniors' notebooks. Okay? I had created those answers before cramming. And I had created those by deeply understanding the whole thing, deeply understanding. So cramming, and then comes at certain stage, even understanding is not needed. If you are cramming those multiplication tables at the age of 8 years, just cram it. Forget about understanding. Just like that twinkle, twinkle, little star. No emphasis on understanding what is twinkling and what is a star, or whether it is little or whether it is very big. Nothing to do about those things. Just cram. Similarly, just cram. Forget understanding. But then at a later stage, when the mind becomes matured, when you can understand, you are ready to understand all those things, then yes, cramming together with understanding. And very interesting incidents in one of the papers on thermodynamics, BSc Honours. There were two questions. I don't know how that paper setter had created, in which some 12 minutes, my 12 minutes, my standard of 12 minutes, answers were common. Two different questions, maybe question number 3 and question number 7 of the paper, right? So the way I had prepared for question number 3, the way I had prepared for question number 7, the first 12 minutes was common. All right. When I saw the question paper, I thought, so nice. So question number 3 solved. Then immediately after that, I took up question number 7. Nothing in between. And the first line was, I have derived this result, this particular equation in the previous question. And after that, I saved 12 minutes. And since I had deeper understanding of the things, I put extra flavor in all the remaining questions also, because I had those extra 12 minutes. So for each question on the average, I had 2 extra minutes. So I could write even better things in those questions, and got very high marks in that particular paper, 87 marks that time, 1970s. 87 at BSc Honours Physics in 1973 was something unimaginable, I would say. So cramming together with deeper understanding, that is the second element. And after that, what comes is thinking. Thinking. If you can think, then yes, you empower yourself. If you can understand, yes, you have to, but thinking is one order higher. Understanding means someone is telling, your teacher is telling, in the book it is written, someone has prepared something, someone has a very nice way of presentation, someone has designed that particular presentation in such a way that you can understand it well. Okay, and then in face-to-face teaching or online mode, whatever it is, if you still do not understand, the teacher is there to re-explain in a different manner. So you are understanding what the others are saying. But thinking starts when no one is there and you are thinking yourself. Then it is thinking. So those cells are different. Understanding cells are different and thinking cells are different. So once you are able to think, whatever is you have understood the thing, you have understood the law, you have understood the equation. What was told to you, you have understood that. But then if questions arise in your mind, then you are thinking. Okay, if you are satisfied, oh, good, I have understood what my teacher has said, and no questions, right? Yes, you have understood, but then you are not thinking. The thinking capabilities are not developed. So the third thing is think over it. Think over it. Think for exceptions. Think for situations in which it will not work. Think for situations where it can be used effectively. Design new situations. Your teacher has given a particular example for that equation. Can you come up with another example, a different example? You can do that if you start thinking on it. So that is the next phase. So cramming, and then understanding, and then next is thinking. So once you start that thinking, then there's one more stage, I will say, element of learning science, and that is exploring. Explore. You can think, you have crammed, you know it, you remember it, you recall it, you can quickly use it whenever needed. Your equations, your formulae, your definitions, your descriptions of experiment, whatever. Then you understand why it is. It is a potentiometer experiment, and people say that if you put the jockey at this end and at the other end, the galvanometer should deflect in opposite directions. Fine, very good. But then you understand it well, good. But then explore on it. Explore, and can you do something which is very uncommon with this? When the galvanometer will deflect in the same direction wherever you put the jockey, can you create a situation? We can. Simple pendulum. You pull the bob in one direction and gently leave from there, and it goes in a circular arc. You count time for 20 oscillations. During this entire 20 oscillation, it is retracing its path to and fro, to and fro, to and fro, to and fro. But today morning itself, I had a physical meeting of physics teachers at my place. Okay, and I put a pendulum there, simple pendulum, simple looking pendulum. There was a spring, and then there was a bob, and I gently pulled the bob and set this pendulum in oscillations. But the moment it started oscillating, very soon it started changing its plane of motion, turning. And in 2-3 minutes, the direction of motion was perpendicular to the initial direction. This is exploration. Thinking, and after that exploration. Can I design a simple pendulum? Of course, simple looking pendulum, I will say, because the standard simple pendulum should only go in the same plane. It should retrace its path. Okay. But then if I know that, I can think. And yes, I have thought everything that, okay, this is because of this, because of this, because of this. But then I am now exploring new ideas. And can I design? With people say, yes, it is simple pendulum. When I asked my teacher, what is this? Everyone said, it is simple pendulum. All right, very good. So let us try to get the time period or look at the motion of it. Simple pendulum, what is the amplitude and what is time period, what is one full oscillation. Let us work on that. But then when I started that, in some 10, 20, 10, 12 oscillation, the plane had changed by 90 degrees. It was started in East-West, now it is North-South. So I could do this because I was exploring what I can do more with it. Once my thinking cells are strong, when I'm able to think, then the next stage is create new situations. So what word is made by the first letters of these 4 elements? Cramming, understanding, thinking, exploring. It's cute. Science learning is very cute. Thank you very much.
Thank you, sir, for this beautiful analogy-based crash course through how one should learn this science. So I really like that child analogy. It tells me that we all know qualitatively we understand science, but when we join school, we get to know the quantitative side of that. So yeah, so now we are up for questions. So related to that, there was a question that you curated 600 plus experiments for students, that too low cost experiments. I mean, how could you do this? Like, how were you able to do this? And could you give us some examples? Did you observe children doing experiments or something like that?
Not really. Not really, because my teaching experiences are, I started my teaching career at Patna Science College. So the lowest class that I taught was 11, 12. And then BSc honors and postgraduate. Then I came to IIT Kanpur. The lowest class I taught was BTech first year. So I'm not really trained on class 6, 7, 8 or 9, 10 or 4, 5, how the children learn there and what do they do. But yeah, general knowledge. Everyone knows. I also know about children. Okay. But then I could do that. See, first thing is I observed in BTech first year IIT Kanpur, the students when used to come there, after so-called cracking of examinations, people always ask how to crack IIT. And I always say that please do not make any crack in IIT. We have built it with great efforts. But jokes apart, the students of this BTech first year, they it's a I do not know about IISER Bhopal, but at IIT Kanpur, almost 90 to 100 students fail in the first year examination. BTech first year semester examination. So 90 to 100 students failed. Why? Why? Because they had crammed, not understood. If understood, at least they have not thought on it. Exploration is very, very dur ki kaudi. So I realized that very naturally what a child learns science in our regimented school college education system, we are destroying that. We are destroying that. We are making a disconnect between the nature and the science education. When we are teaching, what things we are teaching something alien. It's not connecting to our daily experiences. And our natural process of learning was to learn from the daily experiences, learn from the events, And that was very effective learning process, very effective. When there was no teacher, no examination, no semester, no timetable, very effective. And in school college system, a total disconnect is created. That inspired me for each topic of science at a school level, at least, can I make an experiment which is mostly based on material that are already familiar to people. I don't need any vernier calipers. Vernier calipers is not a familiar object. All right. But a plastic scale, yes. A bottle, plastic bottle, yes. A container, yes. A glass tumbler, yes. A rubber balloon, yes. A rubber band, yes. Toothpick, yes. That chakla belan in kitchen, yes. That jharna, karchil, yes. That bat, ball, yes. Tennis racket, yes. So if I can understand law of refraction or magnetic field by the current or polarization of light or electromagnetic waves, using materials which are already familiar to me, most of it, say 90%, 10% is okay. You put one galvanometer, that is unfamiliar object, but if 90% of the things are okay, then that that flavor of natural learning comes, right? People do feel yes, this is how the events take place, and okay, this particular principle or this particular equation is reflecting here, so that adds to the joy. So that was the inspiration, and that is how I took every topic which I could think of in class 6, 7, 8, 9, 10, 11, 12, to some extent BSc also, but mostly in this at the school level. And I started designing, okay, what can be done, what can be done, what can be done. So short experiments, because basically you have to connect it. After that, the mathematics and other things, quantitative measurements, that is easy. But to understand the phenomena, to feel that phenomena, to make a connection between an algebraic equation or a differential equation and some event which is taking place. So that is how I started it, and that is how I developed. And your data is in fact old. We do not have enough workforce to update our profiles at different websites. So this number is now more than 1,000. And every second day we will come up with a new experiment. All right, and it's very easy, we can do it because we have gone through or we have practiced that cute learning process. I can explore, I can explore new things based on my understanding and thinking.
Thank you, sir. Being a physics student, listening to you today gave me a complete new perspective of looking at science, and it was like a dream coming true talking to you. We have some students who wish to interact with you just for a few moments. I would like to ask everyone who wants to talk to sir just to raise their hands. Sachin, you can unmute yourself.
Sir, I am a JE aspirant. I am a dropper actually. I had a question that JE preparation is to be made just like a higher order mathematical equation, exhaustive with numerical approach. There is no experimental basis of this preparation. Just like your books look like a fascinating book, which may increase my dopamine. Actually, I am saying, sir, thanks. But sir, how to come over from the pressure of JE preparation? As a dropper, our teacher said that you have not to ask any question, you have not to do that, you have not to do that. Actually, today I'm studying Newton's laws of motion. I had a question through on which Newton. I have to question on Galileo fallacy, that why sir always ball came side there to there. Is there what happened there if there is a collision? Sir, how you can talk collisions in Newton's laws of motion and others? So how to deal the pressure of as a JE aspirant about that? How to make physics as more interesting?
Yes, Sachin, this is a very common problem, and people who think they have this problem. People who do not think, they do not have this problem. Okay, if you stop after understanding, then your life is cool. Okay. But if you go for thinking, then all these complications will arise. My solution will be, or my suggestion will be, that treat learning and preparing for an exam as two different entities.
Okay, sir.
Both are to be given importance. Preparing for an exam is a very important thing you have to do. If you are decided to go for JEE, put your every effort to score well in the JEE mains and advance.
So actually, sir, I have to pursue physics, but coming from a very middle class background, I have just an option of IIT or ISC for pursuing physics.
And that's okay. That's okay. Perfect. What I'm telling is, whatever examination is ahead, whether
Yes,
it
sir.
is a competitive examination or it is a semester examination or it is a board examination, once you get to some good institution, there you will have internal examinations, mid-semester, this, that, blah, blah. Whatever examination is ahead, you have opted for.
Yes.
Put everything to get good scores in that examination. It may involve cramming without
Yes.
understanding. It may involve cramming with understanding. It may involve thinking. It may not involve thinking. So
Yes.
strategies for getting good score in examinations are to be evolved, to be chosen, to be made and followed. But if all your effort, 100% of your effort goes into that, then you are a loser. But you are not learning. You are not learning. You are not empowering yourself. The learning aspect is very small. The
Yes,
learning starts in this understanding and thinking bracket. Cramming and understanding bracket is a different, and understanding and thinking bracket is different. There is small overlap.
Okay.
Okay, there is small overlap. When you are preparing for examination, some learning takes place, but that is not enough. That is not enough. So my suggestion is that say 90% of your time can go in preparing for the examination, but then 10% you decide that 10% of my time is for learning, and at that time I will not have examination in the mind, and I will start thinking. So there are all these new questions that you have on different things which are not relevant for examinations. Those questions, if occurs to your mind, yes, explore on that, think on that, work on that. So you can decide that, all right, in a week, okay, or in a fortnight, let us say, one day, 124 hours will be there where I will not think of JEE. And in those 24 hours, I will read articles, I will look at the same Newton's laws of motion, but then I will look for new systems, new experiments which can be designed, new kind of situations that can be created, new problems. You create J-like problem, do something new, explore. Okay, so you decide how you will get that 10% and how you will have your timetable. So if this process is on, and every 10 days, 15 days, 7 days, you have a session, you have sessions, you have few hours where you say that bye-bye JEE, not allowed, JEE not allowed to enter my mind. These 4 hours is not for JEE. And yes, in these 4 hours, I will create a new poem. I will create a new poem. Presenting some scientific Bernoulli's principle in a poetic form. Fine, do it. Okay, so that capacity of thinking should not die. For one full year, if you don't think, then your capacity to think will go down. When you go for first year in some IIT or some ISER or some university, you will not be able to think. And that is how IIT Kanpur BTech first year, so many students fail. Go by that. Okay.
Thank you, sir. So, Rita, you wanted to ask a question, right? Please go ahead.
Namaste, sir. Thank you so much for gracing this occasion. So I wanted to ask a question on behalf of several female students. So as as per your experience as an instructor all these years, as a mentor for so many people, how do you perceive the participation of women in STEM fields, especially in physics? What scope do you see, and do you think the numbers are improving? And how do we take these numbers? Do we take them linearly, or what do they really signify? And what else can be done to bolster female advocacy in STEM fields?
Okay. Somehow I never discriminated female and male. All my thinking goes in the same way. Yeah, but I can understand that the social situations are different for this section and that section. But I don't know. I don't have much answers. He says social scientists will perhaps be better in a better position. But what I see is that somehow if I can make physics learning or science learning attractive and something which can be achieved, something which is not that only you have to do very hard work, a lot of hard work to do science, go for arts and commerce, that will be easier. So if that perception can be broken, and that perception is not wrong at such, the way we teach physics and chemistry and biology and mathematics in our schools and colleges, that perception is correct. This much. So if we can improve our teaching learning process in the institutions, schools and colleges, and especially in schools, because the stream is decided at school level itself. Okay, so our class 6, 7, 8 type of science, if that can be presented in a way so that people can, yeah, I can also do that. I can also do nothing very difficult about that. We have started a session, an activity where we go to some village or some marketplace and put a table there. And some tablecloth, and we will put some science experiment there. And then, out of curiosity, why this nice looking table with a nice white tablecloth and some material, some bottle, etc. on it, people will come there. And we will show our science experiments to a layman and make them understand the gist of it. No vocabulary, no special words, but what is happening actually there in their own language. We are doing this kind of programs. Any village randomly we will make no announcement, prior announcement, and our team workers, some 3-4 students, and it is done by students, by the way. It is done by mostly class 8-9 students. The class 8-9 students are conducting that program. They, of course, come to our center and they interact with us, and okay, they are spending time with us, so their own vision is developed in that way. But this program of teaching science to a person in the marketplace or in a proper village, nothing, at any place where you see that, okay, there is a space, it will not cause a roadblock. We'll put our table there, and these 8-9 students will start talking of various kind of experiment, the pressure and increase, decrease of pressure, water flow, this, so many things, charges attracting things, many things, they will do it. So I think if it can be made simple, and if this feeling goes in, yes, it can be done, perhaps the female participation will also increase.
That was a very holistic way of seeing it. Thank you, sir. Thank you for your views.
Thank you, sir. As the number of questions are overwhelming, please let us know
You can
what.
give my email address. You can give my email address. They can write to me. And I'll
that's
answer.
that's
Try to
very
answer.
generous. So we will have just one or two more questions, and we will then. Isha, please unmute yourself.
Yeah, thank you, sir. Good evening, sir. First of all,
Good evening.
sir,
Good evening.
I was saying that India is a developing nation, and how could it be developed taking science into consideration? Means nowadays then there are certain initiatives by the government of India to establish a certain domestic startup make in India projects. So, sir, do you think that science plays an important role in the development of the nation as a whole?
Yeah, very much. In fact, very much, without any doubt. Because science has so many faces. Science is so simple that even a 2-year child can understand. And then science is so powerful that whenever there is any kind of crisis, a problem, people only look towards science to solve it. Plus engineering, of course. Science and engineering. That's the STEM, what you call. Any kind of problems, science plays the role. Whether it was COVID management, energy problem, soil, whatever, climate change, whatever, bigger problems. And a large nation and a powerful nation, or a nation which is becoming powerful, will have many problems and many challenges, internal and external. You have to build a very strong society to keep your nation ahead. And strong society means you are able to solve your problem yourself. And science is something which will do that. And therefore, proper science training is crucial for India to become developed and to remain developed. And that is why I'm so conscious that even from the very early ages in our primary schools or in our middle schools and then high schools, the science training is done in the right fashion, so that people can be empowered with. And there, this exploring is very important. Once you want to apply science to solve your society problems, then this capability to explore new ideas and use that science that you have learned and understood is very important. And therefore, from the very beginning, we should go for this model of cramming, understanding, thinking, and exploration. Okay. So, can we wind up now?
Yes, sir. Arihant, you want to say?
Yes, sir.
So, thank you to everyone, the whole team of the ISR Bhopal is conducting the Singularity.
Thank you very much,
To
sir.
make my evening so beautiful, so fruitful, so useful, so entertaining. Thank you very much from my side.
Thank you, sir.
Thank you so much, sir.
Thank you, sir. Thank you for coming. Thank you, sir.
Yes, sir. Our Singularity was gracious and inspired by you, and it has a wonderful start with you as a speaker. Thank you very much, sir.
Oh, thanks.
Thank you.
Thank you everyone for joining. And hope
For the rest of the people,
yeah,
for the rest of the people, please don't leave right now. So the trailer release will happen at 8. Okay, it has already happened. Here's the link in the chat. So please go and watch this trailer created by Yatharth and Adarsh.
Thank you so much for attending, and we are really sorry we couldn't take all questions because of time constraints. Hope you would understand.
For the people who are asking for the email address of HC Verma sir, it's readily available on IIT Kanpur website. You can have a look there. He has a certain section of the questions box. You can like drop in the question, but please do not spam them. Write concise and genuine questions only. You can go to the website of IIT Kanpur, and he will be readily available there to take up your questions. So thank you everyone for joining. Hope you enjoyed interacting with Dr. H.C. Verma. Thank you.
Thank you, guys.
Thank you, guys. Thank you.